the second part of chapter 12.5 for math 1325. So this we used to call this course like 176, but it's 1325. All right. So for this part, we're gonna move the material to exam 3. So part 1 would be part of the exam 2 material. So if you look at here, we are talking about taking the second derivative. And beside giving you the information, when the when first derivative is 0, it means critical values, right? And if you plug in the particular number and second derivative and you get a positive, remember, is going to be happy face, positive people. So you're going to have a concave up graph. And because at this particular point it's supposed to be a critical value, if you have a graph like that, it kind of implies to you that you're going to have a local minimum point, because that would be the lowest point of the graph, right? When you have a concave upward graph, that would be the lowest point of the graph. And if the first derivative is 0, meaning it's a critical value, and the second derivative is a negative number, meaning a concave down, negative people usually set, right? So if you have that kind of curve, then you're going to have a local maximum point, because you're going to have a highest point here. And but if you have a first derivative equal to 0, but you plug in the same number to the second derivative equal to 0, this means it's inconclusive. We cannot tell what that is. All right, so this table a little bit summarize what happened here. And the next theorem says second derivative test for absolute extremer on an open interval. So they say first derivative equal to 0 is a critical number, and second derivative is greater than 0. Then if it's a open interval, then it's going to have an absolute minimum. So even though this is going forever for the domain, negative infinitive to positive infinitive, because it's a concave up like this, like second derivative equal to positive, so it's going to be a concave up, which means this point over here is going to be the lowest point of the graph, so it becomes the absolute minimum. It's a local minimum, but it's also an absolute minimum of the graph. The next one, again, first derivative is 0, is a critical value, and then the second derivative is a negative number. Negative people is sad, right? So you have a sad face parabola, like that. So even though it's an open interval, with the domain is negative infinitive to positive infinitive, this point is still going to be the highest point of the graph. So that will also be your absolute maximum. It's a local maximum, but it's also your absolute maximum. So for this page, we kind of talk about taking the first and second derivative. And when you found those, you can find the critical number or critical value by setting the first derivative equal to 0 and solve for x. After you have that, you use x equal to that number, which is your critical number. If you plug it to the second derivative, when you have a negative outcome, then you have a concave down, and that is your relative and also absolute maximum. And if you plug into the second derivative here, you get a positive, which means concave up, then that's your relative minimum or your absolute minimum. But if you plug into the second derivative is equal to 0, then this test failed and is inconclusive. So it could be relative or absolute max, relative absolute mean, or neither. So this is kind of like an overview of what we're going to do in 12.5 part 2.